are tangent. The addendum's always the top half of that, the addendum's the bottom.
And the radial line, that's not something that matters.
The radial line's just out of the center? No, but we will have to, we actually get, when you draw the base circle, there's a linear section right here that matches on that radial line, and we'll use that. But it's going to be based on how many teeth are on the gear. So we're going to use that radial line, but again, it's not really going to be shown.
So the part under the base circle is linear, and the part over the base circle, is that involute?
Yep. That's correct. And in fact, that's why we're on that topic, because we're going to get ready to go there real quick. Let me kind of review. I'm going to use this as a lead-in. Any questions on that definition sheet before I lead it? Okay. This is in essence how we're going to draw it right here. This goes along with the example in the text. I just turned the page. I'm on page 624. So in essence, what we're going to do is we're going to lay out our pitch diameter right here. Okay, we know that dimension. Okay, what is that dimension on your sheet? Your pitch diameter. Number 4.167. We've got that. Now, once we get that, and that's the center line, we're going to then offset for the addendum. What value is that? Okay, you see that on your deal where you calculate it? It's the fourth one down, 0.0833. Okay. Then we're going to offset for the dedendum. The dedendum's on page 2 of your deal. You're going to offset 0964, right?
So when you're constructing the base circle, you start with the addendum?
No, you start with the pitch. Offset for your addendum and dedendum. Okay. Now, once we do that, then we've got to determine where the base circle goes. You're going to use the pressure angle for this. Okay. So what we're going to do is we're going to find a point along the pitch diameter. And all we need is a tangent line. They've just done it right at the top because it's easy to draw. So we're going to draw a tangent horizontal line to the pitch diameter. Then we're going to take that line and we're going to rotate it, our pressure angle. In the case of yours, off of the catalog, what's our pressure angle? 14.5 degrees. So what we're then going to do is we're going to take this line right here and we're going to rotate it 14.5 degrees, about that point. Now the base one that does the profile then comes from the center perpendicular to that line, and that's how you find the base. Okay, because that's the radius of it. Once you have the base circle, okay, then we're going to come over and we come in. This is that straight section, that's that radial line. That is, it's that line right there. That goes from the root to the base circle. Okay. Then we'll have little r, which will go right here. Big R, which then goes to the top to approximate that involute shape. So little r goes from the base circle to the pitch, and then from the pitch to the addendum is big R.
How do you know where that is on the line?
Well, we know we're coming up and we're hitting this spot. So you're going to start it right here. If I just take a circle and draw it equal to this radius, it'll cross this base somewhere. That's the center. And then just draw it back and keep that little section.
So how do you know where to start that?
Based on the number of teeth. We'll get there.
Okay.
Is the angle between big R and little r, is that still 14.5?
Nope. No, it is not. Now there's one other little trick to this when we get to it, and I want to kind of explain it here first, and then when we get to it, we'll explain it again. When you get little r and big R, you're getting them off of the odontograph down here. Okay? Now, one thing that's buried in the instructions of this, okay, and when you're doing these, okay, so on your handout, starting here on section 20.4, page 622, the shape of the tube. Okay, so they're basically coming through and they're telling you to draw all these circles. With over here, there's an example right here on how to use Wellman's odontograph. And it's kind of buried in here. But there's an important section. Okay. Right here. Okay. So they grabbed for this example with 20 teeth, they said R is 4.02, little r is 1.56. And that's right off the chart. But this is the only place they tell you. You have to take this for a full-scale drawing and divide it by large P. What's large P?
Pitch.
Gear
No,
diameter.
Gear diameter.
it is a pitch, but it's a different type of pitch.
Whatever diametric.
Gear
pitch is.
diameter.
It's a
The gear
diametral
diameter.
pitch. Okay, so whatever number we pull off of that chart, we're going to have to divide it by 11.999. Because that's your diametral pitch, right? So that's just a little trick. It's hard to pick up on how
So
to
that's-
get.
That's not something we did already here, the divide by P.
Right. This is during the drawing process. Okay. Now, here's kind of my goal on this, is I want to draw both gears, not to completion today, but get them started. What I would recommend, I want to go through and draw the spur first. As soon as we're done doing it, what I would like you to do is maybe try and redraw it on your own once or twice, so that it's stuck there. Okay. And we'll give you about an hour, hour and a half break, and then we're going to pick back up probably about 11, and we'll draw the worm gear. And again, this afternoon, maybe you can practice on it. Now, we may push that back depending on how time goes, and we only do one today and the other tomorrow. We'll see. Okay.
No.
All right, let's go to CAD, and let's draw this thing. Did everybody use it in your 2020 now?
No.
No.
We need to find a time to go through and
Reset everything.
and reset all our basics. Do you guys want to take time to do that? So you're using 2020?
What's,
Well, I'm in 2020, it won't let me open 2019.
I
so-
know, I wanna see what else is
that.
It is.
Oh, really?
Yeah.
All my stuff opens just fine.
They like kicked me out earlier this week. and it won't.
yeah. So can you have one drawing that you kind of flip-flop back between 2020 and 2019? No?
Yeah, I haven't looked at it yet if they changed that deal yet. We'll find a day very shortly where we go through and reset all our paper space and our operating units and all that stuff. We forgot probably how to do it. It'd be a good little review. It actually fit in quite well with our next course, customizing AutoCAD. Okay, so let's start with the blank screen. You're going to be on a C template, so you might want to start that or. First thing you want is a cross that you're going to build this around. So this is going to be the center of your gear. Now we have some established views, so I'm going to zip off this real quick just to remind you. In your handout on page 627, this is really an established view for gears. And that's why we're going to duplicate it. So just keep in mind what we're doing. We've got our spur gear, which sits on a shaft. Okay, and there's a hub that sits on here. You can see the hub right here. Okay. Our gear is identical to this, but I don't think we have the front hub. We got the back hub. Okay, I can't remember. It's on the catalog. Okay, so in essence, we're going to draw the gear profile in a half section on top, ANSI simplified section on the bottom. Now, why is this inside this bold line right here? Does anybody know why that is?
What's that? Say that again?
There's this bold outside section that goes all the way around this gear.
That's because that's what you're seeing behind.
Remember we talked about this thing being dished?
Oh, yes.
Okay, so we've got that dish right there.
Yeah.
Okay. We're going to draw everything right in the center of this.
Why doesn't the section go all the way through then?
What's that?
Why doesn't the section go all the way through? Is there a section? just-
Because it's a half section. You mean stops here and doesn't go this way?
No, I mean, it should be in the middle.
I see.
You get what I'm saying? Like, there's only 2 rings where it's sectioned, and it shouldn't be the whole thing if it's in the middle.
Here and here.
Yes.
Okay. What's the thin part in the middle? The web,
Oh.
right? We do not section webs if they give a false sense of mass.
Okay.
So yeah, we're cutting through the web here, right in the middle of it, but it's very, very thin.
Okay.
Remember all those rules we had back with
Yeah.
sectioning?
Can you put the gear under the light so you can see it?
Okay, so we're drawing everything. So here you can see the dish quite well. We're drawing everything right on the middle. That line that's on the outside of this, that's this line you're seeing here in the background, that thick, bold object line. Okay. So we're going to do all the profiles on the throat because that's where everything happens. And then you'll just see that outside in the background. Okay? So don't let that confuse you. That's kind of why I wanted to go over that.
But the question, the outline in the background isn't a circle, isn't it still 2? Isn't it still
Yeah, but we're just going to draw a solid line on it. Because we're showing the cube profile.
2?
Yes, because really,
We should outline.
if we're looking and we saw this, what we'd see is this go like
Yeah,
that, right?
Exactly, yeah.
As we saw it curve into the back.
Mhm.
Okay. But that leaves a misleading view, so. Okay, so this is where we're going. All right, so everybody's got horizontal, vertical line. We need to draw the pitch diameter. Okay. So I'm going to put a circle in here. My pitch diameter. Make sure you use the D signification. Because you don't want a circle with a radius of 4.167. You want a circle with a diameter of 4.167. I'm going to load a couple line types up here. And I want my fan on line too. Okay, I'm going to leave all my stuff white and I'll try and use line forms, but you can change it to whatever color you're at. Okay, so my pitch diameter, I like them to be center lines just because they're going to be. Okay, let's offset now for the addendum and dedendum circles. You could go ahead and redo a circle and calculate these as the pitch plus 2 times the addendum is 1, pitch minus 2 times the addendum is the other. Or you can just do the offset command. So I'll do an offset of 0.0833, and that goes out, and 0.0964 goes in. And if you wish to, these two will be phantom lines on the bottom part of the drawing. So you should kind of be looking here, where you should have phantom for the addendum circle or base circle, root circle, Center line, pitch diameter, phantom, addendum. We good so far? Okay. Next thing we want to do is lay out where the tooth is going to occur. Now, a couple of you asked this question, and I said, we're going to do it based on the teeth when you ask those questions. Here's the point where we're going to do it. Okay, we're on the spur gear. I've got a radial line that comes up here. And in essence, if you look at the diagrams on 624, you'll see that the edge of the tooth comes up into the base circle. But how many teeth are on the spur gear? Okay, so does it make sense that really we've got to lay off 100 spaces? Because it's got 50 teeth, that also means we need to have a tooth come in between all those other 50. So we've really got 100 spaces. Because as you look at it, so I've got a gear tooth.
Oh, you're saying you have the 50 gears and 50 spaces.
That's right. Because when we're looking at it, we're going to have a gear tooth that comes something like this. Now there's going to be another one over here that does this, right? Okay. So really we've got one tooth, there's going to be 50 of these on the spur. There's going to be 50 coming into it, so we've really got 100 spaces for teeth here. Okay. So therefore, when we take this, what's the angle from here to the side of that tooth?
3.6.
3.6 degrees. And you can just array that line 100 times if you want. We're only going to need a couple of them. Okay. But the angle is 3.6 degrees. So I'm just going to copy.
Wait, repeat that. I'm
The
sorry.
number of teeth is 50.
Yeah.
Okay? And, well, let me kind of show you. No, I just read it in here this morning. Where is it? Okay, it's on page 624 of your handout. Very top paragraph on the left. I'm following the example here. The teeth may be spaced around the periphery by laying off equal angles. Okay. So I'm on page 624 of the handout. They're talking about the radial line. The number of spaces should be 2 times n, where n is twice the number of teeth, or n is the number of teeth. So we've got 2 times that. So I took 50 teeth from the spur gear, times it by 2, that's 100. Divide that into 360, leaves 3.6 degrees for each tooth. Does that make sense?
Yes.
Okay. So I'm just going to copy, you can do it however you want, you can use array or whatever, I'm just going to copy this right on top of itself and then rotate one of them about the center and I'll go minus 3.6. So I've got these 2 lines. So my tooth is going to look like this. Just like that, when I'm done with it. Okay, we now got the edges of the teeth. Now I'm going to move to the base circle, and this is explained on page 622 but it goes with figure 20.4 in your handout. So if you look at figure 20.4, what we need here to get our base circle is we need a line. So I'm going to come off this one that's right off the pitch diameter here, and I'm just going to draw myself a horizontal line. Make sure it's horizontal. And I'm just going to move it in. So it should be off of the pitch diameter. So we need a line tangent, so this right onto that pitch diameter. Okay, y'all good? All right, now the next thing we want to do is we want to rotate this for the pitching, the pressure angle, because we're going to find the base circle here. So I'm going to use the rotate command. If you'll just watch me for a second. Okay? Because it's important that you rotate and use your base center right here on the pitch. So I'm going to do a rotate on my horizontal line about the pitch diameter. So it's rotating right about there. And in this case, I'm going to rotate it at 14.5 degrees. Okay? Because that's the pressure angle of this tube. So go ahead and rotate that. Okay, everybody's got that? Now you're ready now to make the base circle. The base circle has a radius equal to the radius from the center of your gear perpendicular to your rotated pressure angle. So I'm just going to do a circle. I'm going to come from the center of my gear and use my perpendicular snap to go perpendicular to that line. So let me change the color of this. Okay, so I made it my yellow line, so you can kind of see it right here.
You want it perpendicular with what?
To your rotated pressure angle. Just like is shown in figure 20.4. We've been going about 50 minutes. Once you get that done, please take a 5-minute break. Let's come back and we'll finish this up.
What's this circle called? Is it
Called the base circle.
Oh, that's the base circle.
Look at this slide. Is it just my eye? This slide looks like it curves up. It's straight. Does it look like it curves? Or is that just me?
So you do a
Look
circle.
like it curves?
from the center.
Okay. Just my eyes.
This one.
When I look at it, it looks like it goes whoop.
Okay, and that's what we
Yeah,
get.
well, maybe, but it
Staring
might have
at
been your
the point.
suggestion that makes it
No.
look that way. You need to, I can, yeah.
I know, I mean, it's straight, but
You've
why are
already
you?
got your name, you've already got your.
Angle.
Yeah, so you just need a circle, and now go, where's your perpendicular stand?
Looks like they're off a little bit.
And now go perpendicular to this line.
Right. Yeah, but still, I'm just looking at the distance. So this is your pitch. Click on that guy for me, will you?
This one?
Yeah.
Okay.
Diameters, 4.17, okay, that's good. Click on the top one.
go over to your slide. Yeah.
974. So that one, I don't think that one may be right. Okay, but that one might be off. So take your pitch, which is this guy, right? And offset that 0964.
There. So right here, right here to page 64.
I'm not sure that's- Okay.
Okay, now where I'm getting that from is here, right?